Hello everybody. Hello everybody. I'm Sam from News Smart Economy. Today we are glad to invite Gil from COZ to introduce how to integrate Wallet Connect in New. Hi Gil. Could you please introduce yourself first, and you can start your workshop.
Hi, hello everybody. We're going to talk about Wallet Connect today. My name is Gil. I'm also known as Melanki on GitHub, and this is my profile. You can check me there. I'm tech lead and project manager at COZ, and I'm going to talk about why we need Wallet Connect and what is the benefits of it before jump into code and show you how to develop your application using Wallet Connect. So today, how the user can interact with blockchain. To interact with blockchain, usually the user goes to a website or a native app and connects with a smart contract, one of our many smart contracts that will access storage and other functionalities of the blockchain. But to communicate with the smart contract, the user needs to have a authentication. So uh, it will require the user signature. So how could we do that? Previously, back in the day, we had a lot of old-fashioned ways to do this kind of things, and I'm gonna show you how not to do it and how to do it today. So the wrong and the right way to sign transactions. The wrong way, providing your own private key. So if you provide your own private key, the application with your private key can sign transactions, but this is very unsafe practice because you will let the application to do anything it wants with your uh, private key. It can authorize actions that you don't want to do, and also steal all of your assets on your account. So this is very unsafe. We usually do this back in the day, but today we have better options. Uh, so the right way today is to trust only your wallet. So you have your wallet application, uh, like Neon Wallet, and you can check your balance. You can send money, receive money from it, and nowadays you can approve transactions with your wallet. So you can connect to a debt using your wallet, and you can approve transactions it sends to your wallet. So the debt can delegate transaction execution to the wallet instead of doing the transaction itself. So there's many ways to do this, but one of the ways is using Wallet Connect. And I'm going to talk about Wallet Connect because it's a very popular solution. It's used by many blockchains, and it's have been used by new from a while now. For a while now, and you can see here it has very expressive numbers, uh, more than 300 wallets, 3,000 applications, and you can check their website to know more about it. But I'm gonna take a brief presentation here of the benefits and how it works. So how does it work? I'm gonna show, instead of reading this, I'm gonna show you a live present demonstration. And you can see all of this on the live present demonstration now. So this is a very simple dApp that I've made to demonstrate Wallet Connect. So here you can select your network. I'm going to use testnet for now. And when you hit connect, it will show this page to allow your wallets to connect to the dApp. Like with you can use a deep link, which will open your wallet automatically. You can scan the QR code, or you can copy and paste the code. I'm gonna simply use deep link because it's easier, and it will open my wallet automatically. So I can use login here, my account. Uh, and it's already showing me the connection prompt to the dApp. So here it will show which network it wants to connect, New3 testnet, and which features the dApp wants the approval. So on the dApp, we can select which features we want. And if the wallet doesn't provide this feature, it will not work. It will the connection will be not approved instantly. So you need to select only the features you really want to use for the wallet to allow these features. So now we are going to use invoke function, test invoke, sign message, verify message, traverse iterator, get wallet info, and get network version. I'm going to talk about these features later, but for now, I'm just going to approve this connection. And now, since my wallet opens up with main network and my dApp is using testnet, it's asking me if I want to switch networks, and I'm going to say yes. Okay, the connection is correct. I can see my dApp here on dApps menu. And now when I come back here, the interface changed to show many different buttons of features for me to test. And this was a very quick demo, right? So that's why it's not very beautiful, but we can then check for instance, Transgas, and my wallet's already showing me a modal to approve this request from the dApp. So it shows me what are the parameters that are being sent from the dApp and how much gas it will cost me, and I can confirm or deny. I'm gonna confirm, and it's done. Here my application showing the transaction ID. So this transfer gas is simply a smart contract call. It's an invoke function calling for the gas smart contract on the transfer method. So you could do anything you want. You can send a transaction to any smart contract with this method, and I'm gonna show you how to do it later on the presentation. So let's get back here. So just a minute. So here are a few interesting links, and I'm gonna send you this presentation on the chat so you can have these links for yourself. So I'm sending a chat message there so you can grab these links if you want. But I'm just gonna show you the pages so you can take a quick look. So this repository is the Wallet Connect SDK from COZ. It's a library on top of the Wallet Connect library that helps you to set up the Wallet Connect for new environment. So it already has all the methods you're going to use on new blockchain. So you can go to installation and setup guide, choosing if you want to use React or not, and then go to usage guide to understand how you can use the methods, invoke function, test invoke, and so on. But I'm going to show you how to do it live now, today. So let's see the other links. This is a very simple React application. It's an example of how to make a that. You can check the code as well. And this other repository is a non-React example. You can check the code here as well. And you can download Neon Wallet to test your application. It's the wallet from COZ. It's a very pretty wallet. And for testing on testnet, you would need some gas. So I would go to this website to ask for gas on the testnet faucet. It's very simple. You can put your address here, verify, and receive 50 gas, which is enough for a lot of days of testing on testnet. So okay, let's code. Let's go to our let's do our thing here. I'm gonna open a terminal window. And we can start. Just a minute. Oh. Okay, I'm gonna create a vanilla JavaScript application, but you can use React SDK to create a React application as well. So let's do this. First, I'm gonna open my workspace and npm create Vite. Hmm. Why is it taking so much? Actually, well, what is it? What's wrong? Okay. My project name, Wallet Connect, that test. Or my first Wallet Connect that vanilla JavaScript, and then install. Oh, actually, let's see. Around that. Okay, let's see if it's already running. Okay, and we have a very simple vanilla application here. I'm gonna open it on my IDE, my first. Where is it? It's here. Okay. I'm gonna use IntelliJ, but you can use VS Code or any other IDE you prefer. So let's do this. Okay. First, I'm gonna get rid of, well, actually, uh, okay. Uh, First, we need to install the dependencies. So I'm gonna install. I'm gonna end the dev here, the dev mode here, and then install City of Zion Wallet Connect SDK Core. If you're using React, you can use Wallet Connect SDK React. There's a very good explanation how to do this on the repository I show you. The documentation is very well, so you can go there and check how to do it, but I'm gonna do it live now. Okay. You also need to install the Wallet Connect library itself, not the SDK from COZ. And I usually install types for TypeScript. We're using JavaScript here, so probably not useful, but anyway. Uh, so the first thing you need to do after installing the dependencies is to set up the client. Uh, for so let's jump to this client setup. Here on our page, we're calling the main script, main.js. So I'm gonna do it as well here. I'm gonna work on this. And let's get rid of these non-necessary things here. And I'm gonna import Wallet Connect SDK. And I'm gonna create a function to initialize our application. So I'm gonna have a variable here to store our data, our clients for Wallet Connect SDK. And here I'm initializing the SDK, and inside it, I'm gonna pass as parameter the sign clients from Wallet Connect library clients. Here on the client of Wallet Connect, we are going to pass the options for it. The options are the properties from your dApp. So to connect to a wallet, you need to say which are your properties, like your project ID, which release server of Wallet Connect you want to use, and some metadata. And I'm gonna show you. So for project ID, you will need to grab one on the Wallet Connect website. It's I'm gonna show you the link, but to be quicker on this presentation, I'm just gonna use my project ID now. So if you go here on walletconnect.com, you can go to dashboard and you can create your wallet, create your account, like sign up here, create your account, and fill, I think three fields, only three fields to finish your registration, and you can grab your project ID is very easy, very straightforward. So don't worry, just go there and grab your project ID. But for now, I'm gonna use one I have here. And you can use my project ID as well if you want simply to test, but for your real DApp application, it's important for you to have your own uh, project ID. So relay URL, I'm going to use simply use the default one, but you could use another relay server if you want. So I'm just gonna dump some simply just this image. No, this image doesn't exist, but it's all right. Okay, so we already set up our client, so we can start using it. The next thing we want to do is to manage a session. So we start our client, and we want the user to be able to connect and disconnect and auto connect with his own account that if he already connected before. So we can do this with a single method. SDK.manage session. So this manage session listen to disconnect events and disconnect automatically, and also checks if the user is already connected and connects automatically. And so after this, since it's already connecting automatically, we want to check if it's already connected and do something, render something on the application. But we're going to do this, yeah. So render after connect. And let's create this function here, but we can work on it later. But yeah, we need to call init. So let's call init here. All right. And I'm just gonna print something here to see if it's working. So let's go there. Let's run the application. I'm gonna open the console here, and it says I'm already connected. Uh, Probably because I already had a connection, but let's refresh this from other application. Yeah, false. I'm not connected. And we need to connect now. We need a button to connect to the Wallet Connect. And this is very easy to do. We just need a button on our web page here. So I'm gonna create a button here. Let's say it's called simply connect wallet and with the connect ID. So we're gonna need to register the interaction when the button is clicked to connect So let's go. Let's do this. Register interaction. So documents, get element by ID, connect, advanced listener click, and connect. And I'm gonna create a connect method here. Connect, connect. Yeah. But before this, we need to actually run this code, register interaction. So I'm gonna put on init here before everything. Yeah. So when and then here on Connect, it's a very easy method. Well, now we simply need to await Wallet Connect SDK to connect. But we need to say which network you want to connect. So I'm gonna use testnet for now. And we need to say which features we want to use. So for now, I'm just gonna put invoke function, but we can put, we are going to put more things here later. And after connecting, we're gonna call this render app connect. So what happens here? When this method is called, the premise is going to be locked here. It's going to be, the code is going to stop here on this routine, on this premise routine, waiting for the user to connect to this wallet. So only after the user approves the connection on his wallet, the second step is going to be made, which is this one. This is very convenient. It's very easy to use. So I'm gonna erase this here and simply put this here and this here. Okay. Yeah. So let's try this. Okay. So we can check our console not connected. So connect wallet. And I can click here, link wallets. And it's showing me Wallet Connect SDK demo once connect. This is the dep name we put there on the meta tags. And this is the image we put there as well. Because the image doesn't exist, it's not showing here, but we want to show a pretty image here to gain trust from the user. So yeah. And this is the network we chose. And this is the method we put there to ask for approval. So yeah, it's already here. It's shown here, Wallet Connect demo. And right here on the console, it's showing connected. All right, cool. And yeah, so well, let's see what we can do now. We should put some other buttons now to test the features and a button to disconnect. And maybe we should show the address of the user as well. So let's do this. Let's put a div here. Uh, which is it's hidden by default. And here we can put the user address. It's very useful to put the user address on your website so he knows which address the dep is connected to. And we can put a button. So disconnect. And a button to invoke function. Yeah. Yeah. Transfer gas feature. Oh, actually, the- yeah. Okay. So let's check it out. Connect wallet. What's happening? Oh yeah. This is simply because we didn't do anything here. Yeah, let's do this. So we're gonna show the after connect div, and we're gonna hide the button. Yeah, now it should work. I was very confused with why it wasn't working. Let's check it out. Oh, I have a typo maybe. What's happening? Mm, um, wait, um, advance. Now it is. Okay. Sorry, sorry guys. So since it's already connected, I can refresh this page as many as I want. It will, what is happening here? The first thing he do here is open the init, register interaction for the buttons, and initialize the client. And when it goes here, he already checks I'm already connected. And since I'm connected, it will render after connect. And it will show the after connective and hide the connect button. So this is why it's every time I open this page, it will be already connected like this. So let's move on. Let's put some code on this transfer gas method here. And I can show you the disconnect later. So let's go. I'm gonna put an interaction for, well, let's copy this. Transfer gas, click, transfer gas. So, and okay. So here we're gonna call invoke function. And first thing we want to send is the invocations. First thing we want to declare is the invocations. And the invocations goes with the script hash, an operation, and some args. So I'm gonna use the gas script hash I copied from the new documentation. I'm gonna call the transfer method, and the arguments I want to send is the uh, from which account is the sender. So I'm gonna put hash 160 here is the type of the address. And for the from address, I'm gonna use the address from the wallet. If it's not present, I'm gonna send a empty string, but actually this is not gonna happen because we're already connected to the wallet. It's just for sanity check. And we're going to put the recipient address here, the receiver address, and the amount we want to send. So I'm gonna put 1000000. Why I'm gonna put this amount of zero? Because the gas token is it doesn't have a float value. It doesn't have decimals. So if you put only one, it's equal to 0.00000001. So instead of sending this amount, I want to send one. So I need to put 8 zeros after it. Because it has 8 decimals. The number of decimals of gas it's 8. It's declared on its smart contract. You can check it out later. But here I'm gonna send an empty array for the data. Yeah, so I'm gonna from the user account to the address I want to send to, and the amount here. And yeah, so now I just need to say how to sign this transaction. And I can put here signers, scopes. And I'm just simply going to put one here, which is, if I'm correct, is called by entry. I can simply put call by entry here actually. And call by entry is to only execute this smart contract. I can put global if I want. So this smart contract has more rights. And since it's the official gas smart contract, I can put global without any doubts. So yeah. And let's check it out, our response. Yeah, let's test this. So my console is empty here, and let's go. Okay, my wallet's already showing me the transaction. The from is the address of my account to the address I put there. See? The amount, data, all right. I'm gonna spend this much gas. Side this one. All right. Okay, transaction pending because we need to wait for the blockchain to confirm the transaction. So, but it's already here. The transaction ID is already here, and we can check if the transaction worked fine on our wallets or on Dora. Let's check on Dora here. So we can go here. Okay. What's happening? Oh, here's our transaction. So send from my account to the other account, one gas token, network fee, you can check out here. So yeah, cool. Um, all right. Um, so instead of transferring gas, as I already said, you can do whatever you want here. You can put your own smart contract script hash here, and your method here, and the arguments here. And you probably already know what are your arguments, but there are a very good explanation about the arguments on the Wallet Connect SDK repository, uh, how to send the arguments correctly. Let me take a brief look here. So actually, where is this? Can go here. The types. So actually, it's not here. Well, actually, it's on another repository. It's on Neon. That it. Sorry for that, guys. Oh, it's actually sorry, guys. Wallet Connect SDK. It's here as well. I just passed through it, uh, but it's no, it's not. I'm gonna fix this documentation, but the documentation is here. I need to link this documentation there on the other repository. Sorry, guys. But the documentation is here. It shows very well about the types and each type you can use. And there's some unit tests as well for the Neon that kit. You can check. Let me see here. Neon Invoker specs. You can check the examples here, sending different types of arguments. And yeah, I'm not going to go further on this. Uh, so, all right. Uh, so now it will be interesting to show you how to disconnect from your wallet. So let's create a method here. And let's have a render after disconnect. And let's simply undo this. Do the opposite. And let's check it out. So when I disconnect, it should. Oh yeah, I didn't put the interaction here. Yeah. So by clicking disconnect, yeah, it's not connected anymore. And maybe let's I think let's open Neon again. This yeah, it's not here anymore. So depth is not here because we disconnect, but let's try again. So I also want to show you that if I click disconnect here, the application will be disconnected automatically. So let's try this because it's not here anymore. And it should, let's, all right. So I needed to refresh the page because I'm not listening to the disconnect event to do this automatically. Uh, but I will need to check how to do this before showing you. So I'm not going go on this direction, but yeah, it's disconnected now. All right, let's try other methods besides transfer gas. So beside invoke function, if you want to just get some data from the blockchain, uh, you can use test invoke. So we're going to use test invoke here to get the user balance. So let's try this. Uh, we're going to use the same script hash because we're going to get the gas balance, calling the balance of methods and some arguments. The only argument we need is the address. So actually you can get the balance of any address, but we're going to get the balance of our own address right here. And signers, blah, blah, whatever. And rest. All right. So let's try this. Let's put another thing here. Get my balance. Okay, let's try this. So in console, I'm not connected. Let's connect again. Okay, it's connected. And let's get the balance. It's done. Since it's testing vote, we don't need to wait for the authorization on the user's wallet because this method is like an auto acceptable method. Neon Wallet is going to simply accept automatically because it's not something that might hurt the user. So we allow the method to go without user authorization. Um, so it's the response is something like this. We have uh, an exception if something occurs. The gas consumed, the notifications, which is interesting to know what notifications the smart contract sent. Uh, the script that was executed, which is very difficult to use, but it's right here. This state, this is very important because if the state is halt, it's because it worked perfectly. But if the state is fault, it means that the execution didn't go well. Some error occurred, and you need to check what happens and show an error message to the user, or something like that. And this stack is the result you want to see. So here on stack, you will see an array of results, and this is what the smart contract is responding. It responded with an integer with this value. So this exact value is my balance of gas. So if we check here on my account, this is exactly how much gas I have. So let's compare. Yeah, it's correct. So it responded correctly. And yeah, we can use this to show the user balance on our application. This might be useful if you want to check if the user has enough gas to buy or to do some invocation on your smart contract that you already know how much it will cost. But actually, this is done automatically by the wallet, so you don't need to worry about this. But yeah, you would like to check the balance of other things, like if you have NEP17 token, if your smart contract is a 17 token, you can check the user balance of your token and show him on your front-end application. You can simply change this script hash to your own if you're implementing NEP17. Okay, what else can we do? We can do other interesting things like sign message. Sign message is a more advanced feature, but it's very, very interesting, very useful. To be honest, I use this on many applications I develop. And I'm gonna explain what sign message does before showing you the code. Let's say your front-end application needs to send something to a back-end application or to a smart contract, that it needs to be sure that it is you that has this information. So let's say I want to be sure that you are yourself and you are attached to another information. This is very difficult to explain to have an example, but let's say let's say you have your Gmail account, your Google account, and I want to be sure your Google account is owned by your address. So I want to have this relationship saved on the smart contracts or on my backend application. So first you log in with your Google account, and probably we're going to get a token for your Google account. And I'm gonna get this token and ask you to sign a message with it. So after you sign this message, the application will have an object that has the message signed, which is the Google token, and it will be signed with your public key. So this object is something verifiable. So I'm very sure you signed a message of this Google token. So I can grab the Google token again from your message, and I can grab your public key. And this is something that is unbreakable. It's unhackable. So I'm very sure that your token is associated with your public key, which is something that is used to identify a blockchain user. So I can save this on a smart contract or on my backend and use the verify method to to grab this information I already told you about the token and the public key. And I can save this securely. I can be sure that you really signed this. So I'm gonna show you how to do this, both the sign and the verify, and you can use this. It's very useful. So sign message. Uh, so it's we're going to sign the message "Hello World." We don't need this actually. Uh, yeah. Just checking. Yeah. Okay. And right here we would put like the Google token. But for now, let's just sign "Hello World." And let's see what it returns. Let's put interaction here. Okay. And I put a button there. I forgot. Okay. So right here, actually this will not work, and I'm gonna tell you because we didn't ask for send message authorization on the connect phase. So this is simply going to, yeah, it's working. Okay, but we should have, right? Oh yeah, this is because sign message is like a default method that is authorized. But yeah, but we should put this right here to be sure the application supports send message. So if we connect to a wallet that doesn't support send message, you want to put this right here beforehand, because otherwise it will fail later, not fail before uh, on the connection phase. And it's important to be prepared for this when the user is connecting, not later on. So okay, sign message. Sorry, I didn't see the response. Let's do this again. Uh, sign message. Actually, I'm opening again. I need to connect again the application. Okay, let's do this. Yeah, the message is right here. So you're not going to understand these codes, but you can use it anyway. I'm going to show you how to use this information. Message hex is the hex of hello world, the message we asked to sign. Public key is the information about the user, the user that signed the message. Salt is something we put to to scramble the message, to scramble the signed data to be not that easy to do a brute force. And data is the signed message. Let me show you how to use this information right here. So I'm gonna simply copy this. Oh, okay. I'm gonna put a verify message. And I want to verify that message. So I, I'm gonna simply let's just let's say we receive a message here, and I want to verify the message. Um, so okay, so just for testing purpose, I'm gonna create a sign and verify message. So uh, okay. Okay, so here I'm just invoking this, uh, getting the response, and putting this response back here on the verify message. So we are verifying. We actually don't do this one after the other. Usually we do this on different environments. So you ask the user to sign a message on one environment and verify the message on other environments usually because well, because you need to use this on your backend application. I can explain this later. So let's try this. Uh, Sign and verify message. Okay, let's do this. I don't know. Oh, yeah, now it closed. I don't know why Neon Wallet wasn't closing the transaction, but now it closed. Okay, perfect. Uh, okay, let's just clean here our log. For sign message, we're going to allow it. And the verify message, yeah, okay, as well. And now it's simply throwing true because, yeah, the message is verified, is correct. So what we're going to do here, what is happening here? Let me try to explain to you. So the sign message is is going to be executed on when the user logs in. And the verify message is going to be executed later when we send this message to our backend. So this is why we're doing this on two different stages. All right. Okay. I already told you the main methods here. Let me just have a brief talk about the other methods you can use, and also talk about other resources you might want to see. So here on Wallet Connect SDK documentation, you can go to usage guide and see other methods you might want to use. So we already talked about invoke function, test invoke, and sign and verify message. But you can also use traverse iterator, which is useful if your smart contract returns an iterator, which is important when you're returning a list. So if your smart contract wants to return a list, paginated list, it needs to use an iterator. And to walk through each page of the list, you need to use this traverse iterator method. So here's an example how to do it. You invoke, you get your session ID and iterator ID from the response, and simply pass this with the size of the page you want to grab. It will be here on the response. There's also another method called get wallet info, which returns if your wallet is using a ledger or not. This might be useful for your application. Get network version returns network information about the network that the wallet is connected to. So the RPC address might be interesting if you want to do something quicker by checking the RPC before the transaction is confirmed, things like that. There's a lot of other information. And there will be more methods on Wallet Connect. We're always bringing more features for dApps to interact with the wallet. So we might want to check out our COZ Discord, COZ Twitter. We are always bringing updates about this. And yeah, also I want to show you that we have another library that I already show you briefly that is called Neon Debt Kit. Neon Debt Kit has this exact same features and more, the same features and more features of Wallet Connect, but not calling with Wallet Connect, but calling locally. So Neon Invoker, for instance, has the method, has the method invoke function with the exact same signature. And this is useful for you if you want to have an interaction that allows the user to choose if he wants to use embedded wallet on your application or Wallet Connect. So you can switch from one another using the same interface. This is very advanced, but it might be useful for you at some point. So you might want to check this library as well. We have Neon Parser, which has a lot of features to parse data from back and forth as parameter for your smart contract or a response for a smart contract. So you might want to check our unit test to see how it works. And we have Neon Signer that does the sign message and verify message without Wallet Connect. And this one is very interesting, Neon Event Listener, to listen to events from the blockchain. So if you want to do something when an event occurs, like a transfer event, you might want to use this to add an event listener, or to confirm a transaction. I want to do something only after the transaction is confirmed. You can use this method right here. It is very useful, so you might want to check it out. So yeah, I think that's it. Already cover the main topics I want to cover on this presentation. So if you have any doubt, please ping me on the Discord. You can go to a new Discord server. Let me open here just to show you. Probably you're familiar with this Discord server. You can ping me here. Just type Gil and you see me here. You can ask me any question about that development. It might be related to Neoboa, or Wallet Connect, or Neon DevKit, or Neon.js, or whatever. Just ping me. I'm available to talk. You can also go to COZ Discord chat server if you want to talk about other COZ topics or even these topics. And yeah, I'm happy to help you.
Hi, Jill.
So that's it.
I think there is one question in YouTube chat room. Maybe you can help answer it. Does the Wallet Connect support using multiple site address to transfer gas?
Yes, we can use multiple. You can use multi-account address, and you can use multiple signers. Let me show you how to do this. So let me think about it for a moment. Yeah, here on signers, where I show you, you can also put an account here. So you can put a script hash of an account here. And so you can put multiple accounts here. So you can put multiple script hashes. So you can sign with multiple accounts here. This is very useful. I think Flamingo does something like this. I think there's plenty of dApps that are using this feature. And we are studying how to make a good user experience to allow multi-wallet signing. This is something we're actively studying right now, to allow the user to pass a transaction to another user to sign using Wallet Connect. So you would send this to another user, and he will be able to sign it, transfer to another user, he will be able to sign. You could have like a signer to be the payer and another signer to be the user. But for now, you can only do this passing the script hash here for your account. But yeah, I hope I answer your question.
Okay, thanks. I think that's all for today's workshop. Thanks again for your sharing, and hope to see you next time.
Thank you, Sam, for having me. I'm happy to have this opportunity. And bye, guys. Ping me if you want. That's it.
Great. Bye-bye.